we present Lantern, a novel, generic, and portable system that generates a natural language-based description of the execution strategy chosen by the underlying rdbms to process a query. In this demonstration, we represent two different applications of Lantern. The first is boredom-conscious natural language description generation and exploration. An audience can generate and explore natural language description of the query execution plan of his or her query through the learner's view here. One can select a database schema between the TPCH and IMDb by clicking DB text. She could input an SQL query or select one from the example queries of the drop-down list. Given SQL query, Lantern provides a natural language description of the audience SQL query execution plan as well as a visualize plan when the user clicks the Submit button. The learner can view a natural language description of the QEP in textual, or view the operator tree in visualize plan and check the natural language description corresponding to the node of operator tree by mouse over. Click the Detailed View button to see a full view of the operator tree. In particular, a rule-based NL description generation framework may often result in learners feeling boredom after reading the descriptions for several queries, due to the repeated exposure of same text to describe the QEPs. To mitigate the boredom issue, we present a deep learning-based framework called Neural Lantern, which provides the audience with diversified NL descriptions of QEPs. The audience will be encouraged to fire several queries and peruse the NL descriptions of the corresponding QEPs to appreciate similar descriptions generated by Rule Lantern as well as how Neural Lantern injects variability in the descriptions. When Neural Lantern is adopted, one may click the Compare button to pop up the comparison panel to display the output results of Rule Lantern and Neural Lantern. The rule-based output is on the left and the neural-based output is on the right. And the difference between the two outputs has been highlighted. As we can see, in Step 1, Rule Lantern outputs perform sequential scan on table Linnetman filtering on L underline extended piece is more than 100 to get intermediate table T1, and Neural Lantern outputs to get a T1 intermediate table. Perform a sequential search on the table Linnetman filter L underline extended piece is more than 100. The sentence pattern and some words have undergone significant changes. In this way, we can mitigate the boredom issue caused by Rule Lantern. Lantern provide the question answering framework to facilitate understanding of the various features related to QEPs. One may ask how many rows are left after Step 1. Or ask what are the operators used. Or other questions can get the corresponding answers. The audience can also give us feedback in the feedback area. An audience can click Poem button to switch to the second application of the Lantern, which is label generation and portability using pool interface. We adopt a form to show the existing poem objects. The audience can create and manipulate the natural language descriptions of different physical operator objects associated with the specific rdbms either by directly writing statements using pool or using form-based interface. One can click Operate with Statement button to input and run SQL-like statements. For example, the audience can query the poem object named index scan and find that the condition column of the query result is false, which should actually be true. Then the viewer can submit an update statement to update it. And she can refresh the form to check whether the modification is successful. Or submit a compose statement, which is used to generate a combined description of the two operators. Or the audience can choose to use form-based interface to create or manipulate the poems. We can search for poem objects by name. For example, an audience can enter hash in the search box to search for poem objects whose name contains hash. or create a SQL Server or other rdbms poem object by clicking the Add button in a form-based manner. The audience can view the newly created operator after refreshing, and click the View button to view the poem detailed information. Click the Edit button to modify the poem object. Or click the Delete button to delete the object. After creating the poem object of the SQL Server, the audience can return to the learner's view and click Switch Database to switch the rdbms to SQL Server. For a submitted SQL query, Lantern generates the natural language description and operator tree of the query execution plan corresponding to SQL Server. Based on the above two applications, Lantern achieves boredom-conscious natural language description generation and exploration as well as the portability across different rdbms.